Have you ever wondered why we can recall the past, but not the future? A question that's been puzzling philosophers and scientists for centuries. Time, in its mystifying nature, seems to have a direction, a flow from the past, through the present, and into the future. This unidirectional flow, or as physicists call it, the arrow of time, is a curiosity that challenges our understanding of the universe. When we think of dimensions, we usually picture the three spatial ones: length, width, and height. Time is often considered the fourth dimension, but it behaves differently. We can move freely in space, back and forth, left and right, up and down. But when it comes to time, we're like passengers on a one-way train, witnessing the landscapes of the past fade away, while the future remains a mystery. So, if time is a dimension just like the three spatial dimensions we are familiar with, why does it have a direction at all? Time, as we perceive it, is quite different from how it is scientifically defined. Now, that might come as a surprise to some of us. After all, we've grown up with the concept of time as a constant, always moving forward, never pausing or reversing. But in the world of physics, time dances to a different tune. To understand this, we must first comprehend that time is considered the fourth dimension, joining the trio of space dimensions we're familiar with: length, width, and height. Just as we move through space, we also move through time. But while we can choose our path in the three spatial dimensions, our journey through time is a one-way street, always leading us from the past, through the present, into the future. Now let's take a moment to appreciate the genius of Einstein. His theory of relativity painted an entirely new picture of time. According to him, time isn't uniform and absolute as Sir Isaac Newton had proposed. Instead, it's relative and can change depending on speed and gravity. Mind-boggling, isn't it? Imagine you're aboard a spaceship traveling near the speed of light. To you, time would seem to pass normally, but for someone observing from Earth, your clock would appear to tick slower. This phenomenon, known as time dilation, is a direct consequence of Einstein's theory. The faster you move, the slower time passes for you compared to someone who's stationary. Similarly, gravity also influences time. Time moves slower where gravity is stronger, so if you were to spend a year at the edge of a black hole, you'd age less than someone who stayed on Earth. This is because the immense gravitational pull of the black hole slows down time. These revelations about time have far-reaching implications, challenging our conventional understanding and prompting us to question the very nature of reality. So time isn't as straightforward as it seems, is it? But why can we remember the past and not the future? Why is time asymmetric? Dive into the heart of this enigma, and you'll find a curious discrepancy. The laws of physics, the fundamental rules that govern our universe, are symmetric. This means they work the same way forward as they do backward. If you could watch a recording of atoms moving around, you wouldn't be able to tell if it was being played in reverse. Yet, our everyday experiences tell a different story. Certain processes in life are undeniably one-way streets. The breaking of an egg, for instance, is a process that can't be undone. The cooling of a hot cup of coffee, too, is a one-way journey from hot to cold. These processes are examples of time's arrow, the direction of time, which points from past to future. They are irreversible, and that's what gives time its perceived direction. This is an aspect of what physicists call the second law of thermodynamics, which states that systems will naturally evolve towards a state of maximum disorder, or entropy. The past is a realm of order, a record of events that have already happened. The future, on the other hand, is a realm of increasing disorder, of possibilities yet to unfold. Thus, the arrow of time points from order to disorder, from past to future. But here's something for you to ponder upon. Why do we perceive time in a linear fashion, with a distinct past, present, and future? Could it be that our minds have simply been conditioned to perceive time this way? And then, there's the tantalizing question of reversing time's arrow. Could we ever manipulate it to move backward, not just forward? If we could, what would that mean for our existence? Could we ever recall the future just as we remember the past? And if we could, would we still be us?